Hello everyone, I'm Oscar Karnalim from University of Newcastle, Australia, and also from Maranatha Christian University, Indonesia. On this occasion, I will explain our research entitled Work in Progress Syntactic Code Similarity Detection in Strongly Directed Assessments. I have 5 co-authors. First, Simon from University of Newcastle, Australia, and Mewati Ayub, Gisela Kurniawati, Rosevin Arta Natasha, and Marisa Caroline Wijanto from Maranatha Christian University, Indonesia. First is the background. So, common forms of cheating in programming are plagiarism and collusion. Both are about illegitimately reusing other people's programs. Detecting such misbehavior is often aided by a similarity detection tool. So basically, the tool reports program pairs that display undue similarity. Then the pairs are examined by the lecturer to determine whether they are suspicious. Most code similarity detection tools are designed to capture semantic similarity, which is type 3 and type 4 code clone. Assuming that each assessment task can have many possible semantically distinct solutions. But there is an issue here. Not all programming assessments are open to multiple semantically distinct solutions. For example, trivial assessments expected to be easy and can be completed in a short time. Strongly directed assessments requiring the student to satisfy constraints. Clearly, their criteria limit the variation among solutions. Imposing the use of semantic similarity detection tools on those assessments might result in all programs being suspected of plagiarism or collusion. Consequently, some detection tools focus on syntactic and/or surface similarity. No studies have addressed the impact of syntactic similarity on strongly directed assessments. So for our contributions, we compare the effectiveness of a syntactic and a semantic similarity detection tool for detecting plagiarism and collusion in strongly directed assessments. Second, we report any irregular patterns that are useful for raising suspicion in such assessments in addition to syntax similarity. As an additional contribution, due to the pandemic, half of the assessments were designed as homework. So we assume that programming collusion and probably plagiarism might arise more frequently since take-home assessments are typically less supervised. Designing programming assessments as homework might result in higher level of similarity. So in here, we compare each take-home assessment task with comparable assessments completed in a lab. First research question, comparing the effectiveness of a syntactic and a semantic similarity. For this case, semantic similarity is GPLAC, while for syntactic one, it is derived from GPLAC by excluding program statement generalization. We have 2 evaluation metrics, top K precision and average similarity degree. And for the dataset, we have student programs collected from 2 algorithms and data structure courses, basic and advanced. In total, there are 1,034 student programs collected from 55 undergraduate students in 69 programming assessment tasks. So for the findings, syntactic similarity detection is more effective than the semantic one. On most tasks, syntactic detection results in at least the same top K precision as seen in the figure. In average, syntactic top K precision is higher by 18%, and the difference is statistically significant. Semantic similarity detection ignores syntactic variation, leading to some difficulties in distinguishing copied pairs. Semantic similarity detection results in higher degree of similarity. Although the difference is statistically significant, it is not really substantial in our dataset. Why? because many of the assessment tasks impose a particular class and method structure, and that resulted in larger proportion of similar code segments at syntactic level. Second, syntactic variation was applicable only to some parts of the solution. For the second research question, we asked the laboratory lecturers to record any interesting patterns while selecting copied program pairs of each assessment task. The patterns were then filtered and summarized by the authors. In total, there are 4 patterns that can be useful. First, verbatim copy at surface level, which is the most obvious. Second, surface level similarities that are uncommon and probably out of context, like unique identifier names. Third, incompleteness or over-completeness of student programs, like having the same distinct output which is different from that specified by the task, or having the same unnecessary program statements or unused methods. The last one, which is the rarest, is the original author's identity, like student ID. So few students forgot to change the ID to theirs. The third research question, evaluating whether homework assessments result in higher similarity. So we compare all take-home assessments from our datasets week 6 onward to another set of assessments addressing the same task but completed in lab, taken from past offerings of the courses. And we use syntactic similarity detection with similarity degree as the evaluation metric. As we can see in the features, take-home assessments result in higher similarity degree. And the increase is statistically significant on all assessments except 2 in which the lab assessments result in higher average degree of similarity. As the conclusion, first, the use of syntactic code similarity detection is suggested as an alternative to semantic similarity detection. The former outperforms the latter by 18% in terms of precision. Second, suspicion can be strengthened by observation of some irregular patterns, like verbatim copying, irregular surface similarities, incompleteness or over-completeness of the submitted programs, and inadequate de-identification. Third, take-home assessment result in higher similarity than lab assessments. The higher degree of similarity might be the result of breaches of academic integrity, and computing lecturers should consider introducing more comprehensive prevention and detection strategies for take-home assessments. For future work, we will propose a syntactic similarity detection that is specifically tailored for strongly directed assessments. We will also validate the consistency of our findings on other courses with strongly directed assessments, such as object-oriented programming and application-oriented programming. Third, we will investigate whether take-home assessments result in higher degrees of similarity than lab assessment within the same cohort of students. Thank you. So in case you have any further inquiries, you can contact me by emails. Those emails are displayed on the screen. Thank you.